Assalamualaikum warahmatullahi wabarakatuh. So for today's lecture, we will uh, learn how to form the decision tree, okay, using the R software. Okay, kalau kita ingat balik previous lecture, kita dah tengok macam mana nak build decision tree, okay, dan kita fokus di 4.5 masa tu menggunakan Weka. Kalau kita ingat balik, bila kita gunakan Weka, dia sangat simple, okay, stepnya sangat mudah, senang nak ingat, okay, dan dia punya output pun senang untuk difahami. Okay, tapi hari ni kita belajar the second software untuk decision tree ataupun untuk classification, okay, kita nak carry out classification, so kita build decision tree, so kita guna R. Okay, dan kita ada two parts. Okay, the first one is simple tree, and the second one is we use the library R part. Okay, so kita akan tengok. Okay, so untuk sebagai refresh balik, decision tree ni dia carry out both regression and classification task. Okay, and it characterized by nodes and branches. Okay, dekat bahagian okay, where the text on each attribute are represented at the nodes, and the outcome of this procedure is represented at the branches, and the class labels are represented at the leaf node. Okay, so kalau ingat balik, okay, kita punya decision tree bentuk dia macam ni. Sorry. Okay, lepas tu ada next attribute, and then last kali tu adalah dia punya decision dia punya class dia. Okay, so kita dah tengok juga banyak jenis ada beberapa jenis decision tree. Kita tengok ID tree, and then the successive of ID tree is C4.5, and then sebenarnya dah ada juga successors of C4.5, dah ada C5. Okay, and then kita ada chi-square automatic interaction detector, mask, card. Okay, hari tu kita dah tengok macam mana nak kira information gain, macam mana nak kira gain ratio, and then tengok pula how naif Bayes punya algorithm. Itu semua adalah how di sebalik decision tree to form. Okay, macam mana pengiraan itu dilakukan. Dan hari ini kita tengok macam mana pula daripada hari itu secara teoretikal, hari ini kita tengok macam mana nak guna software. Okay, so decision tree in R program language. Okay, let us consider the scenario where a medical company wants to predict whether a person will die if he is exposed to the virus. So the important factor determining this outcome is the strength of his immune system, but the company doesn't have this info. So since this is an important variable, a decision tree can be constructed to predict the immune strength based on factors like the sleep cycle, cortisol level, supplement intake, nutrients derived, and so on of the person, which is all continuous variable. So, bila decision tree ni bukan hanya categorical variable sahaja, kita boleh carry out decision tree atau classification, continuous variable juga boleh kita gunakan untuk decision tree. Okay, so working on decision tree in R, we have partitioning part. So it refers to the process of splitting the data into subsets. So the decision making strategy split greatly affects the accuracy of the tree. So many algorithms used by the tree to split a node in subnodes, which result in overall increases the clarity of the node with respect to the target variable. Okay, then kita dah belajar juga mengenai pruning, okay, and then selection of the trees, and then important factors to consider while selecting the tree in R is, the first one is entropy, okay, mainly used to determine the uniformity in the given sample. If the sample is completely uniform, then entropy is 0. Okay, and then information gain, statistical property which measure how well training examples are separated based on the target classification. So the main idea behind constructing a decision tree is to find an attribute that returns the smallest entropy and the highest information gain. So let now examine the concept with the help of an example, okay, which is the case that most widely used. Okay, reading skills dataset by visualizing a decision tree for it and examining its accuracy. So dalam PDF ni saya dah sertakan apa code yang awak boleh guna balik, okay, guna awak punya R software. Just copy saja setiap setiap kod ni dan awak akan dapat result yang seperti dalam nota ni juga. Okay, so kalau nak asah awak punya skill boleh try, okay, by yourself. So this is the library that you have to import and load. Okay, so you have to import the libraries. Okay, library, dataset, Ketus, Party, DP, LYR ni and this one. And then you have to load the data set. So you use the data set reading skills. Okay, kalau yang macam ni maksudnya data set yang memang ada dalam R software. Okay, and then head reading skills. Okay, so kita bila head reading skills, kita tengok apa dia punya head dia, attribute dia, native speaker, age, shoe size, and then score. Okay, and then as you can see, there for columns, native speaker, age, shoe size, and score. That's basically we are going to find out whether a person is a native speaker or not using the other criteria to see the accuracy of a decision tree model developed in doing so. So, bila kita call out, okay, kita guna code head reading skills ni, kita boleh tengok dia punya data tu, and then daripada sini kita dapat kena pasti mana satu kita punya class, mana satu kita punya features ataupun kita punya variables. And okay, so kelas kita adalah native speaker, yes or no ni lah. Okay. Dan kelas selalunya memang bersifat kategorikal. Okay, tak kira lah sama ada hanya 2 kelas ke ataupun lebih. Okay, itu adalah untuk kelas. So yang age, shoe size dengan score ni akan jadi kita punya variable kita lah. So splitting data set into 4:1 ratio for train and test data. Okay, ingin saya ingatkan macam hari tu dekat dalam WK saya guna ratio 7:3. Okay, and then we can also use ratio 6:4. Okay, dalam contoh ni dia guna ratio 4:1 ataupun 8:2 lah. Untuk pengetahuan awak, okay, untuk ratio for train and test data ni, kita tak ada restriction. Okay, mana satu ratio yang paling baik. Okay, untuk tahu mana macam mana kita nak dapatkan macam mana kita nak tahu ratio mana yang baik, itu melalui awak kena buat testing sendirilah. Maksudnya if awak guna ratio 7:3 tu dapat result yang tak berapa cantik, so you can always change your ratio to 6:4 or 4:1 like this. Okay, so tak ada restriction yang mengatakan mesti guna ratio 7:3. No, tak ada. Okay, so maksudnya when you do the test, you do the analysis, bila dapat result, then you have to decide, okay, which ratio that you want to use. Okay, mana yang dapat result lagi baik. So untuk contoh ni diberikan ratio yang digunakan adalah 4:1. Okay, sample data. Okay, so sample split reading skill split ratio 0.8. Okay, kat sini. Maksudnya kalau guna ratio 7:3, so kat split ratio ni you use 0.7. And then train data subset reading skills sample data is equal to true. Okay, and then test data subset reading skills sample data is equal to false. Maksudnya kat sini, okay, train data and test data ni true and false ni nak memastikan apa yang dah berada dekat dalam subset train data takkan ada dalam subset untuk test data. So kalau nampak dekat bahagian kanan ni saya ada tulis beberapa step. Itu adalah step, okay. Tulisan cakar ayam saya tu, okay. So ini adalah step macam mana kita nak carry out classification ataupun kita nak buat decision tree. So you have the first thing, okay, kalau kita tak ada masalah missing data etc tu, the first thing that you have to do is splitting your data, and then use train data to make a decision tree. And then test the data using the test data, and then you have to find your accuracy. So separating data into training and testing set is an important part of evaluating data mining models. So hence it is separated into training and testing set. So after a model has been processed, by using the training set, you test the model. Okay, itu tadi part splitting. And then kita nak create the decision tree. Okay, kita create decision tree and then kita plot the model. Okay, so this is model C3 native speaker. We use the train data. Okay, ini takut awak tak nampak. Okay, native speaker and then train data, plot model. So the basic syntax for creating a decision tree is C3 formula data. So where formula describe the predictor and response variable and data is the data set used. In this case, native speaker is the response variable and the other predictor variables are represented by. Hence, when we plot the model, we get the following output. Okay, so tadi native speaker tu adalah kita punya kelas kita tadi, okay, the response variable. So dia macam ni cara awak nak masukkan C3 native speaker and then kita guna train data, then kita plot model kita. So this is the output of the decision tree. Okay. Okay, kalau kita tengok, ni adalah bentuk decision tree kita. Okay, saya padam sikit, bagi clear. Okay, awak boleh nampak. Okay, if score, okay, less than or equal to 38.685 and age is less than 6, then sekali lagi score less than or equal to 31.086. Okay, then not a native, sorry, is a native speaker. Okay, from the tree, it is clear to that those who have a score less than or equal to 31.08 and whose age is less than or equal to 6, okay, are not native speaker. And for those whose score is greater than 31.086 under the same criteria, okay, for those who greater than score, okay, greater than 31.086 under the same criteria, they are found to be native speaker. So, statement di bawah ni menunjuk kepada this first branch. Okay. Ada beza. Dia dekat score, kalau less than 31.086 kat sini, dia adalah native speaker. But then, for greater than 31.086, it is they are found to be native speaker. Kalau greater native speaker, kalau less than not a native speaker. Okay. Okay, next is we have to make a prediction. So test the people who are native speaker and those who are not. So untuk for prediction, okay, we use test data. So predict model, predict C3, okay, test data. So creates a table to count how many are classified as native speaker and how many are not classified. So okay, ni awak sendirilah yang buat. Okay, table, test data, okay, native speaker, predict model. Okay, so we can see this is we call as confusion matrix. Kalau kita guna WK hari tu, memang kita akan terus dapat dekat bahagian output tu, akan terus dapat confusion matrix kat bawah tu. Awak boleh semak balik. Tapi kalau guna R ni, awak kena tulis, kena code lah, kena untuk dapatkan dia punya confusion matrix. So the model has correctly 13 people to be non-native speaker. Okay, but classified at an additional 13 to be non-native, and the model by analogy has misclassified none of the passengers to be native speaker when actually they are not. Okay, so bila kita dah dapat confusion matrix, okay, sebenarnya kita boleh kira dia punya accuracy. So, this is how you want how to determine the accuracy using R software. So, the accuracy for test is to be found 0.74 or 74%. Okay, the accuracy test from the confusion matrix is calculated and found to be 0.74. So hence the model is found to predict with accuracy is 74%. So you can see that decision tree are very useful algorithm. They are not only used to choose alternative based on expected values, but they are also used for the classification of priorities and making predictions. Okay, that is for C3, okay, ataupun simple decision tree using R. Okay, next we will see how to do the decision tree using R part package. Okay, so this is for R part. Okay, how we want to the very first step is how to import the data. Okay, kalau tengok kat sini, bila menggunakan yang R part ni, dia ada the first thing kita set seed dulu. Okay, kena set seed, and then this is how to import the data. Okay, this data is from the GitHub user content. Okay, so untuk kalau awak memang dah simpan sendiri data awak dalam komputer, kena ubahlah macam mana cara untuk call data daripada awak punya directory. Okay, so head Titanic, so kita boleh nampak kat sini dia punya this is for data Titanic, awak boleh nampak kat sini. Okay, this one is number, and then this is class, survive, name, sex, age, batch, ticket, fare, cabin, embark, home, destination. Okay, so kita tengok pula dia punya tail. Okay, apa beza head dengan tail tadi? Head tadi, okay, head ni untuk bahagian data pada peringkat awalnya, tail pula yang di bahagian hujung. Okay, so kalau kita tengok, okay, from the head and tail output, you can notice the data is not shuffled. So this is a big issue. Okay, when you split your data between train and test set, you will select only the passenger from class 1 and 2. So no passenger from class 3 are in the top 80% of the observation, which means the algorithm will never see the features of passenger of class 3. So it will lead to poor prediction. Okay, maksudnya bila awak jumpa data yang tak shuffle, so what you have to do is you have to shuffle the data first. Okay, so to overcome this issue, you can use the function sample, okay, shuffle index, so sample 1 to n row Titanic, so head shuffle index. Okay. So dia akan shuffle supaya dia punya kelas tu bukanlah daripada kelas 1 sampai 3 tu tersusun macam tu sahaja. Okay, so you will use this index to shuffle the Titanic data set. Okay, so dia dah shuffle, dia akan dapat data berbentuk macam ini. Okay, ini adalah satu kalau kita hanya belajar teori saja mengenai classification dalam kelas, okay, kita tak akan tahu teknik sebenar untuk buat classification ataupun decision tree ni menggunakan machine learning tools. Okay, so ni pun adalah salah satu the very first step that you have to do once you get your data. So kena pasti dulu adakah data awak dalam keadaan yang memang dah teratur macam tu, ataupun awak perlu shuffle terlebih dahulu before awak carry out awak punya analysis. Okay, next is you have to clean the data set. Okay, drop variables, home desk, cabin, name, X, and ticket. Why? Because all these variables are not needed for our decision tree classification. So yang tak perlu masa hari itu saya dah beritahu, you have to drop. Okay, create factor variables for P class and survive. Drop the NA. Okay, so bila data kita ada NA, so you have to drop that NA, ataupun hari itu kita dah belajar juga macam mana kita nak fill in the missing values. So you can do that. Okay, so untuk yang contoh ini diberikan adalah drop the NA. Okay, so kita guna library dplyr ni, and then drop the variables, clean Titanic. Okay, select negative C, home, desk, cabin, name, X, ticket. Okay, convert to factor level. Okay, mutate P class, factor P class level C1 to 3, labels C upper, middle, and lower. Okay, kalau awak tengok tadi data awak, dia punya kelas dalam bentuk 1, 2, 3. So, sama juga macam dalam WK, kita kena tukar dalam bentuk apa namanya, categorical. Okay, jangan guna numbering ataupun numerical. So, ini adalah cara macam mana awak nak tukarkan data awak daripada okay, kelas tu nak tukar daripada 1, 2, 3 ni awak tukar kepada upper, middle and lower. Okay, and then survive, factor, survive, level C01, level C no to yes. Okay. Okay, ni dia pun tukarkan. Okay, untuk survive kita ada level dia 0 dan 1 dia tukar kepada yes and no. Okay, so okay, this is the explanation. Okay, the code explanation. This one is for dropping the unnecessary variables and then P class kita tukarkan tadi, and then NA.omit is to remove the NA observation. And then sama juga macam tadi, you have to create the train and test set. Okay. Untuk contoh ni dia gunakan 0.8. Okay, 0.8 juga. And then you can test your function and check the dimension. Okay. Okay, so bila kita nak check dimension, you can see, okay, 836 and 8 for data test. Okay, so the train dataset has 1046 rows, while the test dataset has 262 rows. So you use the function prop table combined with the table to verify if the randomization process is correct. Okay, in both dataset, the amount of survivors is the same, about the 40%. So kita nak tengok data kita, okay, the amount of survivor untuk kedua-dua data, adakah dia punya percentage sama ataupun lebih kurang sama ataupun tidak. Okay, so next we have to install the rpart.plot. So rpart.plot is not available from Conda libraries. You can install it from the console. So install package rpart.plot. So you are ready to build the model. The syntax for rpart decision tree function is okay. This is the syntax for rpart decision tree function. So the rpart formula is data method. Okay, so formula, the function is to predict data, specify the data frame, and then class for a classification tree, ANOVA for a regression tree. So you use the class method because you predict a class. So library rpart, library rpart.plot. So feed, okay, rpart survive. Okay, ni dia kita punya class. Data kita data train, method kita class. So rplot feed is feed extra 106. So code explanation, okay, method survive is for formula of the decision tree. Okay, and then the data train is the data set. rpart.plot feed extra 106, okay, to plot the tree. So the extra features are set to 101 to display the probability, and the second class used for binary response. So boleh nampak ini adalah macam mana bentuk decision tree menggunakan rpart package, okay, dalam R. Okay, this is how. Dia boleh nampak kat sini berapa persen dia boleh display kat sini. Ni 0.94, 22%. Okay. Okay, so you start at the root node. Okay, at the top, it is the overall probability of the survival. Okay. It shows the proportion of the passenger that survived the crash. 41% of the passenger survived. Okay, this note asks whether the gender of the passenger is male. Okay, if yes, then you go down to the root left child note, def 2. Okay, 63% are males with a survival probability of 21%. Okay, okay, and then in the second note, you ask if the passenger, okay, male passenger is above 3.5 years old. If yes, then the chance of survival is 19%. Okay, yes pergi ke kanan, so survival dia adalah 19%. Okay, you keep on going like to understand the features impact the likelihood of survival. Okay, note that one of the many qualities of decision tree is that they require very little data preparation. Okay, in particular, they don't require feature scaling or centering. So by default, our part function uses the Gini impurity measure to split the knot. So the higher the Gini coefficient, the more different instances within the knot. So step 5 is to make a prediction. So you can predict your test data set. To make the prediction, you can use predict function. The basic syntax of the predict for our decision tree is as follow. Okay, so you want to predict which passenger are more likely to survive while the collision from the test set. So you will know among those 209 passengers which one will survive or not. So this is how to predict. So predict fit data test type class. So predict the class 0/1 of the test set. So the testing the passenger who didn't make it and those who did. So this is for you have to you want to do the confusion matrix. So table data test survive predict and sin. So the code explanation. Okay, this code is to create a table to count how many passengers are classified and pass away compared to the correct decision tree classification in R. Okay, so this is the confusion matrix. So the model correctly predicted 106 passenger but classified 15 survivors as dead. Okay, by analogy, the model misclassified 30 passengers as survivors while they turned out to be dead. Okay, so the confusion matrix, the confusion matrix is a better choice to evaluate the classification for performance. So the general idea is to count the number of times true instances are classified are false. So kita memang untuk decision tree ataupun untuk classification, kita memang akan gunakan confusion matrix untuk kita punya part evaluation. Dan lain-lain values yang awak boleh dapat dalam WK, dalam contoh dalam output WK ada ROC, TP rate, FP rate, itu juga boleh kita gunakan untuk perbandingan. So each row in a confusion matrix represent an actual target, while each column represent a predicted target. So the first row, this matrix consider that passenger the false class. 106 were correctly classified as dead. Okay, so 106 are correctly classified as dead, so it is true negative, while remaining one was wrongly classified as survivor is false negative. So the second row considers the survivor, the positive class were 58. So this is true positive, while the false negative was 30. So you can compute the accuracy test from the confusion matrix. So this is the accuracy test, okay, using the confusion matrix. So from the confusion matrix, the accuracy for this data is 0.7847. So you have scored 78% for the test set. So you can replicate the same exercise with the training data set. Okay, so okay, untuk topik ni, okay, awak punya bagi awak punya group project mana yang yang buat classification dah boleh start. Okay, dah boleh start untuk explore. Okay, mana satu software yang awak rasa sesuai untuk awak gunakan bagi carry out you punya project. Okay, and then untuk next lecture, next week kita akan explore Python pula. Okay, kita akan explore Python dan akan continue sikit lagi part untuk classification before kita enter to clustering part. Okay, so that's all for today. I hope you enjoy exploring R software for classification. Thank you.